Dr. Jerry Bergman is with me. Dr. Bergman, how good to have you with us.
Thank you.
Dr. Bergman is one of our most credentialed guests, having 2 Ph.D.s and a half a dozen master's degrees in various areas of science. His background included, in 1979, losing his position as a professor because, for no other reason than the fact that he did believe, or he doubted Darwin and believed in creation. And so this is really something that happened in your life that was not only career-altering, but really has had quite an impact on your entire life, hasn't it?
Yeah, very much so.
And one of the results of that is a book that the name of our show today, Persuaded by the Evidence, is also the title of this book, Persuaded by the Evidence, same title that you and Doug Sharp have written together. And tell us just a little bit about this book.
Well, the book basically summarizes accounts of why people became creationists. And one thing I focused on was the fact that so many people believe that creationists are, well, they're born that way, or they're raised that way, and that's why they're creationists. And we wanted to show that many people became creationists because of the scientific evidence. In fact, many people in the book, including myself, became creationists by the evidence, not because we were raised this way. And this is why I titled the book, Persuaded by the Evidence.
It's very important because the other side is always saying that we are so blinded by our superstition and our religion that we are unable and incapable of objectively looking at science, and this certainly refutes that, doesn't it?
Yes, it does, and that was one of the purposes of the book, because most people in the book have PhDs in science, and many are practicing scientists.
Right. Well, now, you have a quote up here from Ernst Mayr, a zoologist at Harvard. I would love for you to talk to us about Ernst for a little bit.
Okay, let me just read exactly what he said, and this was a strong motivation for writing the book. One of the most influential evolutionary biologists of our time was Ernst Mayr, who was, of course, professor at Harvard. And he said that, quote, no educated person any longer questions the validity of evolution, which we now know to be a simple fact. And he's been claiming this, by the way, for over 40 years. In 1967, he said, evolution is accepted by every scientist, he says. And for this reason, it is no longer necessary to enumerate painstakingly the proofs for evolution. Now, when I read this, I thought, gee, I know many PhD-level scientists that do not accept evolution as we defined it. And in fact, I started to make a list of these scientists, and I ended up with over 3,000, and this is my list here. You can see it's pretty extensive.
Yeah, I'm just looking at a page, and every name on this page has a PhD after it almost. I think there's maybe one there that's a DDS, whatever that means. But it's PhD after PhD. And, you know, it's interesting that you've assembled 3,000 names of creation scientists, particularly in light of some of the other shows we've done that have talked about the tremendous persecution that sometimes scientists have to go through when it's discovered that they're a creationist.
Yeah, that's a very good point. I would have had many more names, but I did not add names to this list unless they were public. So they were public with their doubts about Darwinism, as I call them, Darwin doubters, or they published books about Darwinism, and it was very clear from the book that they did not accept the Darwinian worldview as I defined it a few seconds ago, or I got permission. And there are many I would have loved to add to the book, but
certainly
I couldn't because
it would have been at their peril.
Right. And in fact, when I came out with the first edition, I did have 3 people write me and say, better get my name off there. I don't have tenure yet. I had actually several professors from Ivy League schools who said, please get my name off there. I don't have tenure yet. So when I get tenure, I'll come out of the closet, but not until then. So I took their names off right away.
A couple of things come to mind when you say that. First of all, I wonder how big a list we could make if we had God's knowledge, how many more PhDs there would be that were creation scientists if they hadn't been persecuted and if there hadn't been prejudice against them because of their faith. And that shouldn't be happening in this country. But secondly, there's a hopeful side to that. I think there are more folks out there who are creationists than maybe Ernst Mayr would ever even suspect.
Oh yeah, many more. Now, many of these are Muslims and other faiths. They're not all Christians. But nonetheless, when you look at the 3 so-called people of the book, Christians, Muslims, and the Jews, there is an enormous number of people that simply don't buy into evolution.
All right, enough about Ernst Mayr. Let's talk a little bit about his definition of of evolution. Can we do that?
Okay, and the way I define it, some people say, no, 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 that's not right. So let's use Ernst Mayer's definition of evolution. By the way, he lived to be 99, and he wrote several books in his last decade of life, and he just died recently, so he's not listening to this program now.
Okay, well, he can't tune in.
Anyways, he defined evolution, he calls this Darwinism, which is actually the term I often use. He calls this Darwinism, and this is his definition. Quote, all supernatural phenomena and causations. The theory of evolution by natural selection explains the adaptiveness and diversity of the world solely materialistically. It no longer requires God as creator or designer. So he's specifically saying that the existence of all life, in fact, the existence of everything, is due to purely natural causes. There's no need to invoke God or any supernatural intelligence at all in anything in what we see around us, living and non-living.
You know, this is an incredible definition, because I grew up for 25 years. I was a pastor in the United Methodist Church, and I would say it's probably the majority of the pastors in the United Methodist Church. One of the tunes that they love to sing is the compatibility between evolution and Christianity. But I think that the people who are really defining Darwinism or evolution, they must chuckle at those folks. I think they are allies that they maybe have with them but don't hold in very high regard, because they're saying that what evolution is about is that there is neither a need for God or a God, which is totally incompatible with for a Christ follower, in my opinion.
Right, that's true. In fact, when I was an atheist, we used to often call these, what they call theistic evolutionists, useful idiots.
Is that right? That would be what they would call them.
And that term was heard over and over again, and they felt they're useful for now. Once we convince the world of the truth of Darwinism, as Ernst Mayr defines it, then there will be no need for religion, and they, in essence, are digging their own grave.
So what was your goal in writing the book?
Besides to show that there are many people who accepted creation because of the evidence, I also find exploration of the evidence helps solidify the position that indeed creation is supported by the scientific evidence. And some were theistic evolutionists who became creationists because of their study of the evidence. But one of my goals was so much scientific evidence out there in support of creationism, and this evidence was, well, it's hard to convey to the common people. And so I wanted to write a book that would be easy to understand by the common people.
A readable human interest story of creationists who have accepted creation based on evidence. It's not that their faith said, well, this is what I have to believe about evolution. It's that the evidence of science brought them to believe in creation.
Right, and many stressed very strongly that I would not be a Christian today if it was not for my study of evolution and my realization that evolution is not supportable by the science, and therefore they became creationists, and then they became Christians.
Do you think it takes more faith to be an atheist than it does to be a Christian?
Oh, clearly. And in fact, there's a book written by Norm Geisler, who you know personally, and he wrote a book titled, I Don't Have Enough Faith to Be an Atheist. And he shows that indeed it takes more faith to be an atheist than it does to be a creationist.
It does, because you have to get something from nothing. That's right. You were an atheist at one point. Let's talk about your own personal journey before we talk about these other guys.
Well, the first thing I looked at when I was questioning my atheism, and I began to question atheism for a number of reasons. One reason was a lot of the scholarship that atheists did, I realized through a lot of reading, was just not valid. Like the claims about Galileo and Bruno, and the claims that the church executed many scientists because of their science. I realized that these claims were just not true. They're just false. And so I became disillusioned with atheist scholarship. And the next step was, indeed, is there any evidence for evolution? Because a major reason why many people are atheists is because they are convinced we do not need a creator to account for the origin of life and the universe. And so this is a foundational doctrine of atheism. And so I decided, well, if this is not true, indeed, if evolution is not valid, then that negates the main reason why many people are atheists. And so then that forced me to look into creationism first and then Christianity later.
I was fascinated by the chapter in the book on your own personal walk to learn that you grew up with a mother who was a Jehovah's Witness and a father that was an atheist.
So I saw both extremes.
And you did, and yet you essentially rejected both in favor of what you came to see as the truth.
Right. That's true.
Okay, that's wonderful. Well, I think you're an incredible example because most of our folks think that we have to be a Christian so we hold on to creationism. And I think stories of folks like you, who it was the science of creation that eventually brought you to Christ, is tremendous. Why don't you go up to the board and talk to us about some of the others in the book as well?
First, I should mention that some of these people in the book were reared Christians.
Yes?
But they held on to their conclusions due to the evidence. So the evidence was important, even in these cases. And my own conclusion is, I should mention, and the conclusion that I used in writing the book was, evolution, which I define again as molecules to man, never happened, could never have happened, and this is based on science, not on religion. This is a very common misconception. People assume that people are creationists because of religion. And in my case, I found many, and most in the book actually, held on or became creationists because of science, not because of religion. And example is, we can see this progression here, which, by the way, I just recently wrote an article about, but this is commonly presented. And when you study this, you find that these are either faked, or they are distorted, or the evidence is very unpersuasive for what they call a monkey or primate to man. Of course, actually, they stress that man has a common ancestor with apes. Man did not descend from apes. But that's a minor point. And another concern, and this comes out in the book, is that dogmatic evolution, I find, is interfering with science.
That's fascinating. It's going to keep us from the advancements we need to make.
Right, because you are looking at the world with very distorted glasses. You're not looking at what's there, but you're looking at what you want to see there.
So we're not dealing with reality.
Right, right. And there are many examples of blinders. And I stress you must look at the evidence only, and this is why, of course, we use the title that we did for the book. And you must not force the facts into an evolutionary interpretation. And this all too often is done. And I could give several examples, but probably one of the most familiar to me is pseudogenes and junk DNA. It was said for a long time, in fact, I remember discussions that I got into with colleagues. They said, Bergman, this DNA is junk, like 95% of the DNA is junk. It has no function. And I say, we can't say that. All we can say now is we don't know that it has a function. And they said, no, look, you cut it out. Introns are removed from the gene, and they're not used, they're not transcribed, they're not translated. Therefore, they are junk DNA. They have no function. And over I argue with colleagues about this. Now it's widely recognized that much, if not most, possibly almost all of this so-called junk DNA now we know has a function. Much of it has a regulatory function.
That's amazing to me. I think today DNA is held in such regard that to think that it wasn't that many years ago it was regarded as junk is kind of scary.
Yeah. And I've seen what creationists were arguing for many years has been to some degree, if not to a large degree, vindicated. And this has, many scientists, by the way, will admit that this has interfered with doing science. We should have recognized at the beginning that, well, we don't know what it does, but let's try to find out what it does and go from there. Well, some examples in the book. Dwayne Gish, his story of his life. He went to University of California, Berkeley. And most people, I didn't really know much about his background until he did a chapter for the book. He was, for many years, was one of the most well-known creation scientists. He's retired now, but he did his work in biochemistry at Berkeley, University of California, Berkeley. He also was a researcher for Cornell and industry for a number of years. Henry Morris, also well-known, and many of us, I didn't know much about his background, and he Ph.D. from the University of Minnesota. He also was a chair and professor of hydraulic engineering at Virginia Polytech Institute and State University, often called just Virginia Tech. And I go into detail, or he goes into detail, in his life, in why he accepted creation. He was at one time a theistic evolutionist. He was not a creationist, a young earth creationist. Another case is Raymond Damadian, who has a medical degree and was a professor of biophysics at the State University of New York. And he's well known for inventing the MRI.
Wow. And
there's been quite a bit written about him and how he developed the MRI. One thing he told me was that when I was developing the MRI, people said, you're crazy. You can't put people in magnets. It's not going to work. You can't do it. Then when he developed the MRI, and it finally was proven to work, and of course now it's a standard technology in many hospitals, then his friend said, you didn't do it. So when he was trying to do it, they said you couldn't do it. When he did do it, they said you didn't do it. Which is, even though he has a legal patent, he had to go to court to protect his patent. He did prevail in court, and he is the legal inventor of MRI.
For the record, he did it.
He did it, yes, he did it.
All right.
Although others improved upon it.
Sure.
But that's common with most inventions.
Oh, yes.
And, but he did the initial work which showed that MRI technology is possible. You can image bodies using magnetic resonance imaging.
And he was a creationist.
And he was an outspoken creationist.
Great.
And there's a chapter about him in the book. Werner von Braun, who was actually the leader of our space program, he was a German scientist. He was captured by the Americans after World War II, brought to America, and he worked on our space program. In fact, he's called the father of the American space program. So whenever I think of satellites and the space shuttle program and the whole space technology program, one thinks of Werner von Braun, who actually was the father of this program. He got us developed so that this program finally became feasible. And here's a picture of Werner von Braun in his office. And C. Everett Koop, well-known Surgeon General. In fact, he probably is the most famous Surgeon General in history.
Wow.
He also is a creationist, and I have several letters that he wrote which talk about his beliefs about creation. And he has an autobiography which he wrote as well, where he talks about the importance of his religious beliefs. He's more well-known because of his opposition to abortion.
That's right.
But nonetheless, he is involved in the accepting creationism. And interestingly, Dartmouth Medical School, which is where Koop graduated from, they recently added a wing to Dartmouth, and it's called the Koop Complex, and here it is.
It looks like you might be able to be a creation scientist and still be successful in your field. As I look at that complex that they built in his name. Quite a man.
He was very successful. It's said that when he began doing work, he did mostly surgery on infants.
Yes.
When he began doing work, the success rate was like 10% for many surgeries. After he perfected the techniques, the success rate became the reverse. 90% success, 10% failure. Adler's one, who I always respected. He was the editor of the Encyclopedia Britannica. He was a professor at the University of Chicago. And he also, which is one of his greatest accomplishments, he developed this series called the Great Books Program, which a lot of people have heard of. And there's the Great Books. He took all the historical writings and selected from those 54 volumes of material of what he considered the greatest people in our history, Aristotle and Plato and various other people. And this set, as far as I know, still in print. Most every large library has it.
Sure.
I have a set. I've had a set for many, many years. It's, in fact, there was a Great Books program where people would get together in groups and study the Great Books work, which he assembled. And C.S. Lewis, it's not too well known that he was a very active creationist opposed to evolution, although he didn't write a lot about it directly. You kind of have to read between the lines to understand what he had to say. He wrote a lot against naturalism, which of course is a central tenet of Darwinism. And later on in his life, he did write a book called The Great Myth. And in that small book, actually, in that he really effectively dissected why evolution could not be true. But ironically, that wasn't published until after he died. He was kind of fearful of being too open about his opposition to Darwinism because he felt that it would detract from his main message, which was a Christian apologetist.
Right.
But he clearly did have major reservations for
that. In fact, it was an entirely different worldview.
Right.
And so it had to be addressed. I would urge our people to read. You call it The Great Myth.
Yeah.
Truly one of the great minds of the 20th century, C.S. Lewis.
Clearly. And there's Cover Magazine, a story about him, C.S. Lewis, on Christian History Magazine. And he's probably most famous for his work, which has been translated into movies and many languages.
Dr. Bergman, as you were talking and writing with the men and women whose stories are told in this book, do you ever come to a point where you think the truth is going to become so overwhelming that the lies simply won't hold water anymore?
It seems that way if you're willing to look at the reality, if you're willing to study and read what people have said and what we found through science about reality.
And the truth will prevail.
Irreducible complexity is the idea that in order for something to function, it must have a certain minimum number of parts. A good example would be a human being. For a human being to function, it must have, absolutely must have, at least part of the brain. It must have a heart to circulate blood. It must have a certain level of blood. Must have certain organs so it can obtain nutrition, etc. So therefore, you can only reduce a human being so far before it no longer is alive. And that, of course, causes death. And we find when we look at the world that just about everything is irreducibly complex. And I should mention, this does not mean that one cannot remove a part. It's often assumed that irreducible complexity means you cannot remove a certain part. It says there's a certain minimum number of parts that is necessary in order for something to function. I conclude that everything is irreducibly complex except what they call the fundamental particles. One set is called quarks. And you may not be aware of that, but there are 6 basic kinds of quarks. There's top, bottom, strange, charmed, and up and down. Those are the 6 kinds of quarks. So they are fundamental particles. As far as we know, quarks cannot be reduced farther. That's it. And the next one is leptons. And leptons we're probably more familiar with. There's electrons, neutrinos, at least electrons we're familiar with, tau neutrinos and muon neutrinos and so on. By the way, quarks are assembled to produce things like protons and neutrons. Protons are 2 up quarks and a down quark produces a proton. And 2 down quarks and an up quark produces a neutron. And then there are bosons. An example of bosons would be photons and gravitons. Everything in the universe is made out of these fundamental particles. And a common example is a mousetrap. It's a very simple example because you can notice if you take away the base, it won't function. It won't work. You must have the base. Now people say, well, wait a minute, what if you take the base away and attach these particles, these parts here, the sections, to the floor?
Well, the floor just becomes the base.
Right, and I point that out to students because in chemistry this is a central concept, and they notice right away, well, you still have a base, it's just the floor becomes the base. So a mousetrap is irreducibly complex for it to function, and we're talking about a mousetrap like this, which functions in a house to catch mice. People say, well, you can dig a hole and catch mice. That's true, but it's not very convenient to do in a house. And periodic table, all of the elements are irreducibly complex. You must have a certain number of protons, electrons, and neutrons to produce all of the elements. And a good example is carbon-12. To get carbon-12, you must have 6 protons, 6 neutrons, and 6 electrons. You cannot get carbon-12 any other way than have 6 protons, electrons, and neutrons. If you have a different number of electrons, guess what? We have an ion of carbon. We don't have a carbon atom. We have a carbon ion. If you have a different number of protons, you of course have another element. If you have a different number of neutrons, you have carbon-14 or carbon-9 or carbon-12. Okay, examples. Well, obviously, radios. To have a radio that functions, you must have a certain minimum number of parts. Television is a good example. When the television was invented, in order to get a television system that worked, you had to have a unit which would pick up the light, which would translate the light into electrical impulses, which would send the electrical impulses through the air eventually, and then you had their receiver which picked them up, which translated them back into light so you could see the television picture. And that's a good example. MRI and so on, another example. Looking at this whole issue is the idea of intelligent design. All that says is that we can look for evidence of intelligence in nature. And the best example, the most common example, is the watch. The watch obviously was intelligently designed because, well, we can see the intricacy, the interconnectedness, and it's also irreducibly complex because if we remove a couple of these gears, it's not going to work. It's not going to function. And this is a good example. We're going now into a bacterium, and now we're going into the wall. This is the wall of the bacteria here. And now you can see parts are being built around it. And these parts have to be manufactured somewhere else. They have to be shipped to the work site. They have to be assembled in the right place at the right time. And they have to be put together so they stay together. You can't just lay them down.
Slow down and tell me again, that was a bacteria, and in its wall, what's being built?
This is a bacteria flagellum which is being built.
Okay.
And you'll notice there's lots of parts here.
Yes.
All of which have to be available, produced at the right time, at the right place, shipped to the right place, and eventually, of course, we end up with this bacteria flagellum. This right here is a jig to make sure these parts are assembled properly. And then this jig is left, it's moved out. Another jig is put in its place. And you'll see the other jig come in here in a second. Here we go. And this jig then allows the last part of it to be assembled properly. There we go. And eventually, it becomes longer, and we have the bacteria flagellum. And there we can see this is the bacteria body itself. In this case, we have, it looks like four flagellum, which allows the bacteria to move around, kind of like a tail. And here we can see how the flagellum itself is built up. Now, it looks pretty simple, but
it's pretty complex.
It is pretty complex. And these are the parts. You can see this is D0, D1, D2, D3. These all have to be manufactured at the right place, assembled at the right time, and once they're assembled, then it, of course, functions as a movable, flexible tail, which you can see here in a second again. I've often wanted students to make a model of this. You could assemble it without glue, and this whole thing would function. And here you can see in more detail the jig. And we can see then the bacteria flagellum. All the parts are named, so we know what they are. And these have all been studied individually. And we can then look at how it is assembled and how it functions.
That's amazing. The complexity of that is absolutely amazing.
They call it a protein motor. And here you can see more details, the same thing. And this right here, this bacteria, this is E. coli, and this has a single bacteria flagellum. And there you can see more details. When one looks at this, it looks like it was designed and built. Looks like it was manufactured.
Engineered and then designed and built.
Engineered, right.
Yeah.
And this has caused a lot of people to just be amazed at the design and the intricacy of even in bacteria. And this is an actual photograph, a transmission electron microscopy photograph of the bacteria flagellum. So we can see indeed that these drawings, the previous were drawings, the drawings are fairly accurate in showing actually the detail that exists in the bacteria flagellum.
It really does. That's amazing.
Yep. And another example is the Helicobacter pylori, which causes ulcers, also is a flagellated bacterium. And the bacteria motor, when we examine it in detail, we find it's again very complex. It has protein rings, it has inner and outer membranes, it has stators, rotors, and many parts which we're familiar with. In fact, the rotor alone can operate at 6,000 to 17,000 RPMs, and it can stop almost instantaneously and reverse itself.
So there's a motor on this, helping with the words, flagellum. That, in other words, this little motor comes out of the back of a bacteria.
Right.
It must be so minuscule. We must be multiplying that thousands and thousands of times.
It's a nano machine, right.
And it lives inside of you.
Our body, right.
And
E. coli.
and it can motor around inside your fluids?
It spins around and it's able to locomote wherever it goes for various reasons.
And it's made of dozens and dozens of parts.
Yeah, quite a few parts. And how do evolutionists explain this? Co-option. Well, they basically say that some other structure, such as a type 4 pili, or a type 2 secretory apparatus, or a type 3 secretory apparatus, this is most commonly used to explain it. And they say that this co-opted or utilized other parts from other systems in order to build this. So in other words, this was here, and it evolved by borrowing parts from other parts of the bacteria and therefore assembled these. The problem with that is, though, is that really is an engineering concept. Co-option. Well, they basically say that some other structure, such as a type 4 pili, or a type 2 secretory apparatus, or a type 3 secretory apparatus, this is most commonly used to explain it. And they say that this co-opted or utilized other parts from other systems in order to build this. So in other words, this was here, and it evolved by borrowing parts from other parts of the bacteria and therefore assembled these. The problem with that is, though, is that really is an engineering concept. When engineers build something, they often don't produce parts from scratch. They look in catalogs and see what parts will fit, buy these parts, and then utilize these in order to engineer what they're trying to. For example, microswitches. There are catalogs which have thousands of microswitches, and when you need a microswitch, basically what you do is look in the catalog and say, well, this one will fit. But that is done by intelligence. That's done by design. You look for what works for your system, say, up, this one will work, we'll order so many from the company, we'll utilize them in our experimental models, and if it works appropriately, then we will order these for production. And the same thing is true here. Co-option must have intelligence. It must have a means of determining whether or not something works before indeed finally functions. But of course, Darwinists don't explain that way. They try to explain it that, well, parts were certainly ended up over here and it worked slightly better, and so those were selected, and so other parts end up over here. But we don't see any evidence of that in either bacteria or other animals. Parts are produced and put where they belong. They're not floating around, and they're not such where they can be, oh, well, let's use this part over here.
There's no trial and error there. Everything is so precise.
Right, it is. And
yes.
We don't see any evidence of trial and error today.
No.
And my study of this indicates that trial and error does not explain it. Now, this is what Stephen Jay Gould would call a just so story, which is not based on facts. It's based on somebody sitting down and saying, well, I think this might work. It's based on thoughts, on ideas. And another problem, too, that co-option has is, where did the parts come from in the first place? Co-option just says that these parts were utilized in order to produce the flagellum, but that doesn't explain where they came from. So we still have that to explain in order to utilize co-option as an explanation. And the parts must be assembled properly, in the right place. They can't be upside down, they can't be the wrong way. They have to be assembled in such a way to where they fit into where they're supposed to go. And of course, they must have a minimum of parts to live. And this is the same problem that Darwin had. Darwin basically said that the solution is infinite variety. He thought that all life had an infinite variety, and now we know that all life has very clear limits. Like humans cannot be 25 feet tall. It simply is not feasible. And so therefore we don't have infinite variety. We have variety, but it's not infinite. Yeah. It's a good point. And he came up with the idea of pangenesis, by the way, which has been proved wrong, which is a whole other presentation. In the flagellum, here we go, there's 23 new proteins, which as far as we know are not found anywhere else. So the idea of co-option, well, where do these 23 proteins come from?
So you couldn't borrow them because they don't exist anywhere else. So actually there is a documentable fact that they can't be borrowed. Right. Because they are nowhere else.
Well, some are borrowed. Some are borrowed.
But there are
found.
23 that have to be produced in that cell.
Right, and are not found anywhere else. And about 70 specified proteins are needed for it to function.
It takes 70 different proteins.
70 different proteins.
Perfectly assembled in the right order and in the right space in order for this to work.
If you have too many of these proteins, you have a problem. You have too few, you have a problem. You have to have close to the right number or very close to the right number, and they have to be assembled at the right place, at the right time, in the right amount before it functions.
Now, when you see evolutionists talking about this, Dr. Bergman, do you sense that they have confidence in their answer?
Well, what they say over, and I've discussed this with many evolutionists, and they say, well, just give us time, we'll figure it out.
Mr. Bergman, we talk about IC and ID.
Right.
And let's be sure that everybody's on board by what we mean by both those terms.
Okay. ID is intelligent design, which ID is a concept which basically stresses the fact that certain things you can look for evidence of intelligence, like a watch. And people who are supportive of this idea feel that you can also look for evidence of intelligence in life. IC means irreducible complexity, and the term is used so much in science that you just say IC. You can remove certain parts, but beyond that certain minimum, and that's the key, beyond that certain minimum, it will not function.
And the more complex something is, the more of those parts there are.
Right, and the more difficult it is to find the position where indeed it doesn't work, because certain parts can be removed, but certain parts cannot be removed. And that's actually what a lot of scientists have done in order to understand, for example, the functioning of the human body. They remove a certain part and the person dies, and they say, well, gee, this is necessary for life.
Whoops. Okay. Well, you know, I'm still kind of stunned by looking at our bacteria and the flagellum that came out of the back, and the amazing thing that this is like a rotor motor
Right. It is
that
a
can
motor.
make it go forward and backward and
Backward.
sideways, can go at different speeds and twist and turn. And the idea that that just happened by chance, I know that moves more to intelligent design than irreducible complexity, but it flabbergasts me. That seems to me, what I'm trying to say is that the more knowledge we have of how complex life is, the harder it is to believe it's here by random chance.
Yeah, that's true. In fact, we found in looking at life that the more information we do research on and the more things we discover, the more difficult it is to accept Darwinism.
Yes.
And a good example of that is when Darwinism was formulating his theory, he had no idea of the complexity of the cell. He thought the cell was about as complex as, oh, a bowl of jelly. And there's an example of a cell. This is the most complex machine in the universe.
Is it one single cell?
One single cell. People spend a lifetime studying not just the cell, but also parts of the cell. Basically, you have a nucleus here, and the nucleus has what they call pores. Pores allow certain things to go in and go out, and the pores themselves are very, very complex because they're selective in what they allow to go in and out. A nucleolus right here, which is where certain assembly functions occur. And then you have the ribosomes right here, the rough, what they call the rough ER. Then you have the smooth ER, which doesn't have ribosomes on it. And so they call it the smooth ER because it lacks ribosomes. The ribosomes are here on a section called the endoplasmic reticulum. So they call it the rough endoplasmic reticulum because the ribosomes are connected to this structure here. And then you have free ribosomes in various places. And you have the centrioles, which help the cell relative to coordinate cell division. And you have the cytoskeleton, which allows the cell to maintain some type of shape and help move things around. The mitochondria, right here, a mitochondria convert food into ATP, which allows the cell to have a source of energy. And this is a very simple explanation of the cell because you can spend a lifetime just studying the mitochondria. I have thick volumes of hundreds of pages which just detail the structure and the function of the mitochondria.
And of course, the question that screams to be asked is, can something that complex just happen?
Right. That's the major concern that people who are concerned about the intelligent design issue have. They conclude, no, it could not have occurred through evolution.
It's one thing to come up with a theory, something else to defend it after you've based everything on it. But I don't think if we'd have seen how complex it is, anyone would even have presupposed that it could have happened by chance.
Yeah, and it's not just complexity alone. We're talking about design complexity.
That's right.
Or complexity that is not just a lot of stuff together, but stuff that is obviously there for a purpose.
It's not just building it, it's engineering it.
Right.
Yes.
And here's a good example. This is kinesion, this little guy here. And it literally has legs here, and this is the leg. And it has feet here which walk on this microtubule, and they carry supplies, materials, building supplies, and so on, from one part of the cell to another part of the cell.
This is within the cell.
Within the cell. And these little guys walk around carrying their loads to where the loads has to go. Because you remember that parts have to be assembled in one place and manufactured in one place, and also assembled to produce the final product, often in another place, like the bacterial flagellum.
And you have to produce a product because these cells die.
Right. If there's continually replacement of all the parts of a cell, this goes on 24 hours a day.
So it isn't just that a cell dies, but parts of it have to constantly be replaced.
Right.
There's a maintenance crew in there.
A maintenance crew which continually replaces parts that don't seem to need replacement.
All right.
But it's more or less on a time schedule. After so much time, these parts are replaced.
All right.
Okay, the court ruled, and this is a case in Pennsylvania, the Katzmiller case, Dover Area School District, and the judge ruled, quote, and I'll quote him, the argument of irreducible complexity central to ID, intelligent design, has been refuted in peer-reviewed research papers and has been rejected by the scientific community at large.
All right.
That's what he ruled. He said there are no peer-reviewed articles supporting Professor Behe, Michael Behe, Lehigh University's argument that certain complex molecular structures are irreducibly complex. But if you think about the material I presented, this is absolutely ludicrous.
Yes.
Because the fact is, everything, especially in chemistry, it's a major concept in chemistry, you have to help students understand the difference between carbon-12, carbon-14, between a carbon atom, between a carbon ion, and carbon and boron are different. How are they different? And irreducible complexity, I should mention, by the way, has been around since Aristotle. They recognize that for certain things to function, you must have a certain minimum number of parts. What is that? Is it a 1? Well, it looks like a 1. Now what does it look like?
A plus.
Looks like a plus. Now what is
a
it?
4.
Looks like a 4. My intention when I drew this was a 4, but I didn't give you enough information in order to show you that, indeed, this is a 4.
You had to have all the parts.
So you have to have all the parts. So
That's right.
Intuitively, clearly, things are irreducibly complex. It's an idea that's been around for a long time. It was central to chemistry, development of chemistry, and so on. And this now has gotten in the media from the net. There's a quote from Amazon, a review of a book. Behe, quote, started out with his conclusion and then set out to reinforce it. Okay, well, that may be true. This explains why you get unsupported assertions such as irreducible complexity. And when I plug this in, by the way, irreducible complexity is false, I got 293,000 hits. So there are 293,000 hits which claim that irreducible complexity is false, and of course that's ludicrous.
Dr. Behe is onto something, isn't he?
Oh, I think he is. He's pointed out something which Darwinists find very embarrassing, and therefore they try to discredit him by name-calling, but I think they must recognize that this concept is valid, it's scientific, it's supportable, and calling him names seems to be the main way they try to refute the argument.
How long can we do that before the truth's exposed?
Court decisions like Judge Jones, I think that's going to set back science for a while, because people will say, well, nothing's irreducibly complex without really thinking about it.